Alright, so I made this little test first-person shooter. It's relatively basic. You just have a little capsule collider for the player, got a little square thingy for the gun, and when you pull the trigger, it just makes a little ball appear wherever it happened to hit. So, it's just a nice little village, nice and calm. Totally didn't just steal this from the asset store. I'll have a link in the description for that. Totally made this all myself. No, I didn't. The nice little calm, little happy village, and suddenly... Alright, so, bad guy place. You bust in, take out the hinges, blow down the door, blow the lights to blind everyone inside, kill the bad guy, and there's the hostage. Save the hostage. You win the game. Great. 10 out of 10. Game of the year. Awesome. So let's take a quick look and see how I did this. This is relatively simple. I threw this together in a day. It's not much. Let's start with the simplest, the bad guy controller. It's literally absolutely dirt simple. All it has on it is a method called die, and all it does is deactivate the game object. That's it. Simple as dirt. Next, slightly more complicated, is the hinge controller, which gets a reference to the door controller. And the script on the door checks the list of hinges to see if there are any hinges left. If not, then it takes all the rigid body constraints off it, meaning that it can now be affected by physics. And then it just makes the hinge disappear. The light controller is a little bit more complicated, but I just, got a little carried away. Wanted to add a little bit of flair to it, even though it's just going to get thrown out after I make this video. It just has a point light and a physical object as a light holder, and when it gets shot, it just starts a timer that changes the light intensity, and once the light is as intense as possible, it deactivates the light and adds physics to the light assembly, so the whole light little falls down. Plus it plays little particle effects, just for show. The chains controller is very simple. It just has a public method on it called break chain that will play a spark effect, the same one that's on the lights, and will make it so that the hostage that is held up by the chains now is affected by gravity, so they fall down, and calls blow chains on the hostage state storage. The hostage state storage just stores whatever state that the hostage is in. I added a bunch of these here just to make it look like I put any effort into this, but really the only ones that matter are the free and chained. When it first created, it's set to chained, but when you blow the chains, it changes it to free. None of this code is extraordinarily performant. None of it is groundbreaking or well written, but it's just sort of a basic idea of what you might see in a basic prototype. The main point of this video is going to be coming up in here, the shoot animation. So the way this works is it creates a physics raycast from the gun point going forward. I really should have had it come out of the center of the screen, but oh well. Changes the position of the little ball to wherever the raycast hit, stores the transform of whatever was hit, stores the tag of whatever was hit, and then goes through a bunch of if-else statements checking the tags. There's a tag for the bad guy, a tag for the hinge, a tag for the light, a tag for the chains, and a whatever else I hit does the thing. Each if segment has a get component for whatever controller is associated with that tag. So the bad guy has the bad guy controller, the hinge has the hinge controller, so on and so forth. And then each has an individual call to whatever method is within that controller that is the thing that happens when it gets shot. So you shoot the bad guy dies. You shoot the hinge gets shot. You shoot the light blows out. If you shoot the chains break. Now this setup is perfectly fine if you're working on a small project or if you're working on a base prototype where you just want to throw something down that works and then never touch it again. The big issue is that every time you want to add something that gets affected by getting shot in a different way, you need to make this if-else statement longer and longer and longer, adding more else-ifs to the chain. It's going to be ugly. It's not going to be as performant as it could be. It's going to be poorly organized, and it's going to get harder and harder to maintain as your project gets bigger. The solution to this is called an interface. An interface, according to the good book, An interface is similar to a class, but provides a specification rather than an implementation for its members. I have no idea what that means. So I searched for a very, very long time to try and find a good description for what a interface is that works for somebody who isn't trained in programming, has never gone to school for, is entirely self-taught, and doesn't understand a lot of the language that they use. So I ended up finding this website, sharpcoderblog.com. I will have a link to it in the description that gives a pretty solid explanation for how to use them. I'm going to describe this by example. I'm going to show you exactly what I do to implement it and why it's such a good idea to use interfaces, at least when they're useful. I'm not really sure every possible case. Okay, so we have to make a new script. Add a new one into our project. I'm going to go create C# script. And we are going to name this I. I stands for interface. It's just regular notation. And can get damaged. Not can get damaged, because everything can get damaged. Can get shot. There we go. You probably can't see this on a regular screen because I got the big monitor. Black Friday, and even I can barely read it just because it's tiny text. So, can get shot. We don't need any of this. No collections or collections generic because there's going to be nothing to collect. Don't need Unity engine. No need for that. Don't need a monobehavior. This is not a non-behavior. Don't need the void or update functions. Don't need none of that nonsense. We just need to take this public I can get shot class and change it from a class to an interface. There we go. Okay, it'll change to green or whatever color you happen to have it set to. All right, so what do we want in our interface? What we want in our interface is whatever is going to be in common between all of the things we want to be able to get shot. So not everything that's going to get shot has health. Not everything has the exact same functions attached to them. But we're going to basically make one method that connects everything together. And all we're going to have is that. Because an interface is not a class. It doesn't have data and methods. All it has is like a list of the things that your classes are required to have. Let's actually make one. Public void. Let's call it get shot. Because get shit. No, don't get shit. Get shot. And that's it. Okay, you're done. Put a thing there. I think. Yeah, is that it? Yeah, that should be it. So, this is an interface. You do not attach, it's not a monobehavior. You do not attach it to any of your in-game game objects. You don't have to do anything other than this. Make sure it's public. So we're going to go to, let's use Hinge first. So in order to implement it, you go to monobehavior, hit space, comma, space, and include your I thought that's how that worked. And be sure to close Microsoft Visual Studio before you attempt to implement it. If I didn't do that and spent the past 20 minutes trying to find whatever error I added was. Okay, so you're going to notice that I add this after the monobehavior and I get an error. That is perfectly normal because this is telling me Hinge controller does not implement interface member I can get shot dot get shot. So I am required to have get shot in whatever class my interface is attached to. So I'm just going to change this one, hinges get shot, to get shot. There we go. Error goes away. Now I'm going to do this for all of the other ones where the function that gets used where the function that is getting used by the gun to have whatever happens when it gets shot happens, if that makes sense. I'm just going to change that to get shot. All right, so we added our interface to each of our classes. We added the method that is attached to it, or more accurately, we changed our current methods to the one that is attached to that interface. Now, here's the thing that makes it actually useful. As you can see, these all no longer work. I no longer need these tags. I no longer need... Here, hold on. Let's actually just take all of this and comment it out, because we don't need that anymore. We don't need a thing for the string. All we need is a single get component. So I have the transform stored as hit trans, and we are going to get our interface. And it is going to get whatever component happens to have our interface attached to it. There we go. Now let's store this as a variable. It's going to be same as every other variable, every other get component. So I can get shot. Let's just call this. I have no idea what to call this. I am terrible at coming up with names, especially on the fly. Get shot controller. That'll work. Now we do have an error just because I left the other else there. That's fine. We'll change that in a second. So, if we actually do get a shot controller, I'm not sure if this will actually work, then get shot controller dot get shot. And now what this is going to do is when we shoot something, if one of the components attached to it has the I can get shot interface attached to it, then it knows that that component has get shot. So we can just call that from whatever we happen to have. So we can get rid of all of this. We can put those tags to better use elsewhere. I'm actually not going to delete them yet, just in case this doesn't work. That tends to happen sometimes. I might have made a small mistake somewhere, but I believe this is all accurate. So now, if we want to add something else to the game that has a completely different effect, has its own controller, has its own reaction to getting shot, we can, like, you know, maybe if we were adding a crate that breaks open and there's a treasure inside or something like that, we no longer need to change our shoot class. All we need to do is make sure that I can get shot is attached to the controller for the crate. It's a very easy way to simplify your code that I could not figure out because I couldn't understand the explanation for it. And I hope I did good enough here, but let's test it. Let's see if it works. It should do exactly the same as our original run. So, okay, we have our nice little village, and alright, let's blow through. Door goes down, no errors so far. Blow the light. Light gets blown. Shoot the bad guy dies. Shoot the thing, Kid falls. We win. Yeah. So that's the use of interfaces. It can, oh, nope, wrong one. It can greatly shorten your code. I no longer need to have these tags, so I can better organize it. And it just makes it so that if you have a very large project that you're working on, you can make use of these. And yeah, that's the main use of an interface. The other thing is decoupling, but I don't really understand that well enough to do it. I'll probably make another video about that later. So yeah, that's it. If you liked this video, please do subscribe. And if you have any ideas for a topic for another show where you'd like me to try and come up with a simple as possible explanation for what is going on behind the scenes for Unity, just let me know. I do like making these videos. I am by no means an expert and very much would like the opportunity to learn more and to teach if I can. This entire mini project is going to get uploaded to GitHub so that you can download it. I will have a link in the description. Anything else? I don't think so. See you all later.